Okay, so hello and assalamu alaikum. Today we have here Cambridge IGCSE Chemistry, paper 4-2, May June 2021. Total time for which is 1 hour 15 minutes. Total marks 80. So let's start. We are given the symbols of elements of period 3, and they're saying we can use them once, more than once, or not at all. And yeah, so we just have to write the symbol. Write the symbol of an element which is malleable. So metals are malleable. So it should certainly be a metal, any metal, Na, and group 2 for group 1 are group 1 metals are more soft and more malleable. Has only two electrons in its outermost shell. So this should be something from group 6. Group 6, because in group 6 it means that it has six outer shell electron. Oh no, sorry. They said it has only two electrons in its outermost shell. So it should be in group 2, because the number of outermost electrons is equal to the group number. So in group 2 we have magnesium. It forms an oxide which leads to acid rain. So acid rain is caused by the oxides of sulfur and nitrogen. So in this case we have sulfur. Forms an ion with a 2 minus charge. So this is group 6, because 2 minus charge means it needs to gain two electrons, and it is an anion, a non-metal. So it should have six electrons originally, and it will gain two more. So it should be two more to get an octet. So this means that in a neutral atom, it contains six outermost shell electrons. So it should be in group 6. So sulfur again is extracted from an iron ore, from an ore called bauxite. So this is aluminum. Recall, pure recall. The ore of iron is called hematite, and this is bauxite. Next, does not form an oxide. So this is chlorine, or argon is more appropriate. Argon is a better answer. Next, forms an oxide with a macromolecular structure. So obviously, we have silicon oxide, which has a macromolecular structure. We have three: graphite, diamond, and silicon oxide, and the oxide is silicon. Forms an amphoteric oxide. The amphoteric oxides mean they can react with bases and acids both, and there are three: Al, Zn, and Z, zinc and lead. So in the options, only aluminum is given. Exists as diatomic molecules. So this should be a gas and not noble gas, because noble gases are monoatomic. So Cl, only Cl2, forms a binary compound with hydrogen that is a strong acid. So a compound with hydrogen which is strong acid. So obviously Cl. H plus Cl is HCl, which is a strong acid. Next, silver has an atomic number of 47. Naturally occurring atoms of silver are 107 Ag and 109. State the name given to atoms with different nucleon numbers of the same element. So these are isotopes in which number of electrons and protons are same, but the nucleon number or the mass number is different. Now we have to complete the table to show the protons, neutrons, and electrons. So the number of protons is shown by the atomic number 47. This is a neutral atom, so the number of protons should be equal to the number of electrons, 47 again. And the neutrons is the mass number minus the proton number. So 107 minus 47, which is 60. Now this, be careful, this is a ion. Protons, same 47, plus there's a plus charge, means that it has lost one electron, which is why there's a plus one charge. So it has a fewer electron than the total number of electrons. As for neutrons, also there will be difference, of course, because 109 minus 47, so this should be 62. If we confirm, 107 minus 47, 60, and of course complete the definition of relative atomic mass. Relative atomic mass is the atomic the dash mass of naturally occurring isotopes atoms of an element on a scale where the dash atom has a mass of exactly dash units. So this is the relative atomic mass. You should be remembering this definition. It is the average mass of naturally occurring atoms of an element on a scale where the carbon 12 atom has a mass of exactly 12 units. The carbon 12 atoms has a mass of exactly 12 units. So it is the relative atomic mass. This is the reason why it's called relative atomic mass. A sample of silver has a relative atomic mass of 108. Okay, deduce the percentage of 107 Ag present in this sample of silver. Okay, so the percentage, if you notice, 108 is exactly in the middle of 107 and 109. So this means that they're both present in equal amounts, 50-50%. And if you want more detail, the atomic mass is the percentage abundance multiplied by the abundance multiplied by the atomic mass, the mass, isotopic mass, which is 107, plus the percentage again, which will be 1 minus x and 109. So, and this we can say it is, if this is x, yeah. So now, if we calculate, 108 will be equal to 107x plus 109 minus 109x. So this will be 107x minus 109x, which will be minus 2x equals to 109. When it goes to that side, it will be minus 1. So if we cancel it out, x equals to 1 over 2. So this means both are present in 0.5, 0.5. So if you multiply this by 100 to get the percentage, it will be 50%. This was just for clarification. Otherwise, I already told you the logic behind it, 50%. Silver nitrate is a salt of silver made by reacting silver oxide with an acid. Write the formula of the acid which reacts with silver oxide to form silver nitrate. So it's an acid means it should have H plus ions, and the forming product is nitrate. So the acid should also contain nitric acid. Aqueous silver nitrate is a colorless solution containing Ag plus ion. Describe what is seen when aqueous silver nitrate is added to aqueous sodium iodide NaI. So what happens is AgI is formed, silver iodide. When sodium iodide NaI reacts with Ag plus, Ag AgI is formed. So this is a yellow precipitate. If this was silver bromide, it would have been cream precipitate, and if this was chloride, silver chloride, this would be AgCl. If this was, it would be white precipitate. So this is also available in your notes for qualitative analysis in your syllabus. Write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium iodide. It includes state symbols. Okay, so if we write this aqueous silver nitrate, this is aqueous plus sodium iodide, which is also aqueous. This will form AgI, which is solid because of precipitate, and sodium nitrate, aqueous. So what happens is the aqueous separate and their charges separate. So this will get a plus, minus, plus, minus, plus, minus, plus, minus. So the same identical on both sides will cancel, the aqueous ones only. So nitrate and nitrate are aqueous, both cancel. Sodium and sodium are both aqueous, cancel. The final remaining is Ag plus aqueous plus I minus aqueous, which will produce silver iodide, a solid. This does not get a charge, sorry. Only aqueous get charges. So 1 mark for AgI as the only product, and as this is the only reactant, this is your final answer. This is what you have to write at the end. Okay. Next, in the positive test for aqueous nitrate ions, aqueous sodium hydroxide, and one other substance are warmed with the nitrate ions. Name this other substance and the gas forms. This is again the notes for use in qualitative analysis. Test for ions. In the nitrate ions, aqueous sodium hydroxide. Okay, so if you look at the test, sodium hydroxide is heated with what? With aluminum foil. So aluminum is a substance which is heated with sodium hydroxide, and the nitrate ions. The gas formed as a result is obviously ammonia. So this is the positive test for nitrate ions, which is given in your syllabus as well. When silver nitrate is exposed to sunlight, silver is formed. Name the type of reaction which needs light to make it happen. Photochemical reactions. Photo means light, chemical means reaction. Members of one homologous series only react with chlorine in the presence of sunlight. Name a member of this homologous series. So we know these are alkanes, which they're talking about. We need one named member. So alkane, we need one named member. Methane, probably. Yeah. Name two products when the compound in one reacts with chlorine. So one is that what is formed if methane reacts with chlorine. So we get a chlorine over here. So this is chloromethane. Chloro, no need to number it. There's only one carbon. Chloromethane, and obviously hydrochloric acid or hydrogen chloride, because there was originally a hydrogen over here and Cl2 was reacting. So one Cl gone here, the other Cl goes with this H, which is substituted. Next, sodium hydrogen carbonate is found in baking powder. When sodium hydrogen carbonate is heated, it forms C products. Name the type of reaction that takes place when sodium hydrogen carbonate reacts in this way. Okay, so this is a decomposition reaction. If there was no hydrogen, then also it would have been there, like we study in the metals. If calcium carbonate is decomposed, it forms oxide and the gas carbon dioxide. So this is thermal because it happens when we heat. Decomposition. Calculate the volume. Okay, we're up with moles. Calculate the volume of carbon dioxide formed at room temperature and pressure when 12.6 grams of sodium hydrogen carbonate is heated using the following steps. Determine the mass of 1 mole of NaHCO3. So one mass of 1 mole is what? Uh, the formula is moles equals to gram over the mR, and because it's only 1 mole, so we just have to calculate the mR of sodium hydrogen carbonate, which will be sodium hydrogen carbonate. So sodium only we need to see 23 maybe. Yeah, 23. So sodium is 23 plus 1 plus 12 plus 48. So this is 84. Now 84, when it goes on to multiply on that side, there is only 1 mole, so 84 times 1 is 84. Okay, next, calculate the number of moles of any HCO3 used. Okay, so we know that 12.6 gram is present, and now we want to know the number of moles. So we know the MR, we know the mass of 1 mole. So the moles can be calculated by this formula again, G over MR 12.6 over 84, which is 0.15. Determine the number of moles of carbon dioxide formed. So we're given the equation, and the mole ratio is given 2 is to 1. When there are 2 moles of sodium hydrogen carbonate, there is only 1 mole of carbon dioxide. So there is the ratio 2 is to 1. 2 is to 1. So 0.15 is to x. Basically, we just have to halve it. 0.15 divided by 2 which will be 0.075. Calculate the volume of carbon dioxide formed. So we know that every gas under room temperature and pressure occupies 1 mole of any gas under room temperature and pressure occupies 24 dm cube, and the formula from that is V over 24. Now we want to get the volume, so V equals to 24 times the moles, 0.075, which will be 1.8. Lime water is aqueous calcium hydroxide. Carbon dioxide turns lime water milky because of white precipitate forms. So calcium hydroxide, the formula, okay. So calcium has a charge of 2 plus, hydroxide has a charge of minus, cross multiply, this will be CaOH and a bracket 2. So this is the formula. The white precipitate that forms when lime water turns milky. So calcium hydroxide was there and carbon dioxide was inserted. So the precipitate is calcium carbonate. Calcium hydroxide plus carbon dioxide. So calcium carbonate is formed. A student carries out an electrolysis experiment using this apparatus. State the name given to any solution which undergoes electrolysis. Obviously, it is the solution of the electrolytes. The student uses dilute aqueous sodium chloride. Okay. Hydroxide ions are discharged at the anode. Complete the equation. Complete the ionic equation for this reaction. So this you should be remembering as well completely. 4OH minus will give us oxygen and water. Explain how the ionic half equation shows the hydroxide ions are being oxidized. Okay, so because the oxidizing is as you know, oxidation is loss of electrons. So hydroxide ions are giving away electrons. Why? Because obviously they have a -1 charge, so they need to give one to become a stable atom. So they're oxidizing agents. You can remember this by oil rig, in which oxidation is loss, reduction is gain of electron. Now, how the ionic half equation shows, it shows because OH minus ions lose electrons. Describe what the student observes at the cathode. So, at the cathode, only a gas would be seen, and yeah, a gas would be seen, and the color we know we have to guess the color, understand the color of the gas. So hydrogen will be produced at the cathode because the cations we have are Na plus and H plus, and H plus is lower in the reactivity series than sodium. So the lower substances, the easier it is for the substance to be discharged and to be deposited at the respective electrode. So H plus is there, so the observation will be just fizzing because hydrogen is colorless. So no color, there will be colorless fizzing only. Write the ionic half equation for the reaction at the cathode. So we'll have to write the equation for hydrogen being discharged. So hydrogen had donated an electron to become an ion. Now it will gain that electron back and it will become H2 gas. So there will be two here and two here for the balancing. Now this the student repeats the experiment using concentrated aqueous sodium chloride. Describe what the student observes at the cathode. So at the cathode, being concentrated has no effect, so there will still be hydrogen, so there will still be fizzing. And at the anode now, earlier we had what? OH minus ions and Cl minus ions. So OH is below Cl in the reactivity series, so OH is more likely to discharge, and when it discharges, oxygen is produced. But now, because it is concentrated, thus the Cl is preferred now. So when Cl is discharged, what happens is chlorine is a gas and it is a green gas, pale yellow green gas. So green gas is the observation. The student added litmus to the solution after the electrolysis of concentrated aqueous sodium chloride. State the color seen in the solution. Give a reason for your answer. Okay, so after the electrolysis of concentrated aqueous sodium chloride, Cl minus has gone to the anode. Sorry, anode is the positive one. So anode, and what was here? Here was Na plus and OH minus and H plus. So H plus went to the cathode, and what remained was OH and Na. So they both reacted to form, as they were ions, NaOH, sodium hydroxide. So sodium hydroxide is a base, so color of the solution will be blue. Litmus turns will be turned blue, will be turning blue. Litmus turns blue because because of formation of base, which is NaOH. So NaOH is the reason. Carbon electrodes are used because they're inert. State another element that can be used instead of carbon, platinum, which is the lowest in the reactivity series of the metals, and it is completely unreactive. This question is about compounds of nitrogen. Nitrogen reacts with lithium to form lithium nitride. Write the chemical equation for the reaction between lithium and nitrogen. So lithium is in group 1, nitrogen is in group 3. Oh, sorry, group 5. Lithium plus nitrogen will be lithium, and they've given the formula, so no need to worry about the formula. Just the balancing you need to care about. So 3 lithium on the right side, 3 lithium on the left side. Okay, but before this, we need what? 2 nitrogens on the right side because we have 2 nitrogens on the left side. So now we have 6 lithiums, so 6 on this side. Lithium nitride is ionically bonded. Complete the diagram to show the electronic structure of the nitride ion. Show the charge on the nitride ion. So, okay, so nitrogen has originally 5 electrons. We just have to draw the nitride. So it has originally 5 electrons in its outer shell as it is in group 5, 2, 4, 5. And now we have how many electrons from lithium? We have a total of 3 electrons to complete the octet. So 1, 2, 3. And the charge will be 3 minus because 3 extra electrons are gained by nitrogen. Nitrogen reacts with fluorine to form nitrogen trifluoride. The chemical equation can be represented as shown. Some bond energies are shown in the table. Calculate the energy change for the reaction between nitrogen and fluorine using the following steps. Okay, so energy taken in to break bonds is the total energy taken in on this side. So 945 plus 3 times 160, which is 1425, 1425. 1425. Energy released when the bonds are formed is on the right side. So we have three three, yeah, 3 nitrogen and fluorine bonds. So 300, and we have this twice. So 6 times 300, which will be 1800. Energy change during the reaction will be calculated by minus subtracting the two. Energy in minus energy out is the correct formula. Energy absorbed minus energy released. So 1425 minus 1800, which will be 375 minus 375. So the reaction is exothermic. Oh, next question is the same. The reaction is exothermic. Exothermic because more energy is released in the bond formation than energy absorbed in the bond breaking. So bond breaking is on the reactant side and bond formation is on the product side. So more energy was here, 1800, and less energy was here. So this explains that more energy was released in bond formation than absorbed in bond breaking. Complete the dot and cross to show nitrogen trifluoride. So there will be three single bonds. Why? Because fluorine is in group 7, it only needs to share a pair of electron, and nitrogen is in group 5, so it needs a total of three electron pairs, which is being fulfilled over here. So total five electrons, so one sharing with each fluorine and two remaining. As for fluorine, it should have a total of seven electrons. So one, two, three, four, five, six, and one shared for each fluorine. Yeah. So this is the correct dot and cross. Yeah. Lithium nitride melts at this, nitrogen trifluoride melts at this. Explain in terms of attractive forces why lithium nitride has much higher. Yeah. So we know that lithium nitride ionic is an ionic compound and this is a covalent compound. So there are what ionic bonding between lithium nitride and there is only a force of attraction between NF3, which in the molecule between the molecules, which is a weaker attraction than the lithium nitride. So the ionic bonds in lithium nitride, sorry, is much stronger than the intermolecular forces of attraction between the intermolecular forces of attraction in NF3. Ammonium nitrate is a compound of nitrogen. Calculate the percentage by mass of nitrogen in ammonium nitrate. So nitrogen, we have two nitrogens in ammonium and nitrate both. So 14 times 2 over 14 plus the formula is mr of desired element over total mr times 100. So 14 plus 4 plus 14 plus 48. So the answer will be, if we calculate it, 35%. See the use of ammonium nitrate, it's a fertilizer, pretty obvious. Fertilizer, ammonium because of nitrogen, and state the name of a compound that will displace ammonia from ammonium nitrate. So there should be a base, and it is used in farming in agriculture, which is calcium hydroxide. Ammonia is a base which forms a weakly alkaline solution when dissolved in water. Define the term base. So bases are proton acceptors, meaning they accept the hydrogens. Proton means hydrogen in this definition. They are proton acceptors. Suggest the pH of aqueous ammonia. Of course, ammonia is an alkaline gas, so it should have a pH greater than 7, but it is not a strong one, so it should be near 7, so 8, 9 maybe. Yeah. Next, molecules A and B can form condensation polymers. Each molecule has two identical functional groups. Name the functional group in B. So COOH is the functional group, carboxylic acid. Draw the part of the structure of this synthetic polymer that will form when two molecules of A and two molecules of B combine. Show all of the bonds in the linkages. So what will happen is there will be ester bonding. The OH from the acid and the H from the alcohol will eliminate and a water molecule will be formed and an alternating arrangement will be there. So O and this O will be extended. So this will be CO again the same, and then from this point onwards we go back to this, so the same thing is being repeated over and over again. COO and oh sorry, this should be O and then C, O, and we had to shade also. So shade. So two molecules of each were asked in the question. So that's pretty much enough. Yeah. Next, name the other product form. Of course, water. We already decided. When polymerization takes place, water is formed. Molecule A is a simple sugar unit which can be made by hydrolysis of complex carbohydrates. Draw the part of the complex carbohydrate that could be hydrolyzed to make molecules of A. Include one linkage and show all of the bonds in the linkage. So this is not in your syllabus any longer anymore. Carbohydrates are not in your syllabus, only proteins are there. State two conditions which could be used to hydrolyze the complex carbohydrate to form A. So this is also not directly in your syllabus, but for hydrolysis we use acid because we need to provide the H again. Name the technique used to identify the individual sugar units made by the hydrolysis of a complex carbohydrate. Okay, so complex hydro the when glucose or when glucose is hydrolyzed by yeast, then what is formed? Ethanol. So that is fermentation. There are two ways to make ethanol. One is addition of steam to ethene, and the other is the oxidation, oh sorry, the hydrolysis of a carbohydrate, so which we do by yeast. When yeast anaerobically respires, ethanol can be made from the simple sugar glucose. State the name. Sorry, my bad. They were saying to identify. Wait. Name the technique used to identify the individual sugar units made by the hydrolysis of a complex carbohydrate. So this is not in your syllabus anymore. As for this, we can still do because this involves a separation technique. The individual sugar units are what are soluble. So when a complex carbohydrate is hydrolyzed, we get simple sugar units, glucose, sucrose, etc., which are soluble in water. So there then to identify which sugars are present, we need chromatography. Even if you don't understand it, doesn't matter. Ethanol can be made from the simple sugar glucose. State the name of the process. Now this is fermentation because on this then yeast reacts to produce ethanol. Complete the chemical equation for this reaction. So glucose forms ethanol C2H5OH and carbon dioxide. Now the balancing, so six hydrocarbons. So if we make a two over here and two over here, so four carbons and two, six. As for hydrogens, we have how many hydrogens? 12. And over here, 2 times 5, 10 plus 2, 12. So O6, so O2, 2 O's plus 4 O's, so 6 O's. So this is the end of it. We have completed the paper. Thank you. Jazakallah khairan.